about cover crops, and then we'll go off and see some tunnels. So this is going to be a video that we're going to start here, and we're going to move over and just cover a couple of different topics in this same general area. So cover crops are a plant that we grow purely for feeding and nurturing the soil, because the soil, it's not only dirt, it's a living ecosystem full of microbial life, full of complex dynamics involving physics, chemistry, biology, right? It's a complex system in the soil, and the interactions between all those components is what creates a thriving, healthy environment that feeds our crop. There's an expression in organic farming, feed the soil, not the crop. And what that means is that in conventional agriculture, they just feed the crop. They use soluble chemicals, synthetics, they fertilize with chemical fertilizer, and the crop soaks it up and grows. But in organic agriculture, we're focusing on feeding the soil microbiology so that the soil microbiology can release nutrients and feed the crop. And so practically what that means is organic matter. Organic matter is compost, organic fertilizer, and cover crops. So plant residues that when they go back to the soil, they get decomposed by the fungi and the bacteria and the earthworms. And as they get decomposed, they release the nutrients in a soluble form that the plants are able to uptake. And so here, what we have is we have our 3-year, our rotation. So in our crop rotation, we have a period where we're dedicating it just to hay. So this is a hay crop. Typically, like in animal agriculture, they would cut this and dry it and store it for the winter and feed it to animals. But our animals are in the soil. So what we do is we just chop it. We just grind it, and it falls on the floor, on the ground, and it mulches and is decomposed. So this is a mix of grass, alfalfa, clover, that's growing to feed the soil. And so here, if you look, you can see the succession here. The first strip down there is the final year of vegetables. So that's going to be planted to cover crops in the fall. Here, right here, this was vegetables last year, and we're in the process of implanting different types of cover crops. So it's mostly rye, and there's some sections of oats where the rye died accidentally. And on top of this, we're seeding clover and grasses. So this rye is going to grow to be about 6 feet tall, and then we're going to mow it, and then the grass and clover is going to come back. And we're going to have 2 years of grass and clover. So this is the second year of the grass and clover, and over there is the final year. That area there will be killing using tarping, which is a technique we'll cover in a couple minutes later in this video. But we're going to tarp it to kill the cover crop, and then we'll be able to prepare it and plant vegetables for the following year. So we have an 8-year rotation with 5 years of vegetables and 3 years of perennial cover crops. And even within those 5 years of vegetables, we're even incorporating cover crops into that. So it's a very dynamic situation. It's like a mosaic. So let's go check out some more cover crops, but on the way, I want to show you these tunnels. So this is called a caterpillar tunnel because of the shape it has. The way it has those little bumps is like a caterpillar. And so just a reminder, please do not go in there. Please don't let your kids go in there. And so these are sheltered environments where we're growing our heat-loving crops. So eggplants, you can see here we have eggplants in the first bed, tomatoes in the middle, peppers on the south bed. And so these are all heat-loving crop in the Solanaceae family. So this is what's sometimes called the nightshade family. It includes tomatoes, peppers, eggplants, tobacco, and potatoes. And so the benefit of the tunnel is twofold. First of all, it's creating more heat, and these are heat-loving crops. And so it's going to help them grow and mature earlier. It also allows us to plant them earlier because we're able to close the tunnel and protect them in case of any late spring frosts. The second benefit is that it creates a sheltered microclimate and protects the crops from the rain. Because what happens when it rains is that the leaf gets damp, and these are crops that are very susceptible to fungal disease. It only takes 4 hours of humid leaves for the spores to germinate and begin the cycle of fungal diseases. And so by creating a sheltered environment, we're able to grow these disease-sensitive crops without using any fungicides. But we don't grow any tomatoes outside, and since we've moved all our tomatoes inside, we haven't had to spray them at all. And so that's awesome. And these tunnels are very low tech. They're just simple metal pipes with a single layer of plastic held down by ropes. They're very mobile, so they actually follow our crop rotation. We move these tunnels every 2 years. So we'll do 2 years of tomatoes in the same bed, and then we'll move on to a different area. Speaking of moving on, let's go see something else. All right, and here we are. This is what tarping looks like. So these are large plastic tarps that we use to cover the cover crop, block the light, and basically kill it because it has no light. And so that allows us to kill the cover crop without working the soil and without using herbicides, because obviously we're organic, so we're not going to use herbicides, which means if we want to kill the cover crop, the most common way of doing that in organic agriculture is through tillage. So that means using some sort of piece of equipment to mix the soil. But unfortunately, when you do that, you actually lose some of the benefits of the cover crop because you're breaking down that little ecosystem, you're introducing oxygen into the soil, it's causing the oxidation of the organic matter, which is good because it helps release the nutrients, it kills the weeds, it kills the cover crops, but it's something that we're trying to experiment about how to move away from tillage. Tillage in of itself isn't bad, but you know, I get bored, so I'm trying to move away from it and develop new systems. And so this is an exciting system here. We have, this is an amazing cover crop, hairy vetch and ryegrass. And so this is gonna get mowed and tarped, and then we're not gonna work the beds. We're just gonna put our organic fertilizer directly on top of the beds, and we're gonna put our landscape fabric, which is like a geotextile with holes in it that we plant our peppers and eggplants in. So these are gonna be beds for some outdoor peppers and eggplants that are gonna be ready later. So we've got our early batch of peppers and eggplants in the tunnels, late batches out in the field, also zucchinis. And so this is actually a no-till planted cover crop that's going into a no-till establishment of peppers and eggplants. Like, oh my God, look at that. We've got a nice little mulch growing on the soil, perfect environment for earthworms and soil microbiology. And this is a massive nitrogen fixer. Let's see if I can dig one up for you and we can see if there's any nodules on there. Let's find a nice plant. Let's see if there's any nodules on here. Oh yeah, look at this. So look at these, see these bumps? So these bumps are an infection of the root, but it's a positive infection. It's a symbiotic infection that happens with legume plants. So crops in the legume family, such as vetch, peas, beans, clover, alfalfa, have a symbiotic relationship with the rhizobium bacteria. And the plant allows the rhizobium bacteria to infect the roots and create nodules. Each of these nodules is full of rhizobium bacteria, and the rhizobium bacteria have a very special ability. They are able to grab nitrogen out of the air and fix it into a plant available form. So these nodules are capturing nitrogen and giving nitrogen to the vetch plant in exchange for carbon. The plant is capturing carbon from the sky, turning it into sugar and feeding it to the bacteria. The bacteria are capturing nitrogen and feeding it to the plant. And when we tarp this, all that nitrogen that's in this biomass, look at all this nitrogen is going to be returned to the soil and released for our crop of vegetables. And so we're able to grow vegetables with less fertilizer. So there you go. All right, well, let's move on to the next station.